we're here in the UK, and we have one of the units, the DentAir units, just in the corner here, which is currently on. So you'll quite happily be able to hear me talk. So you'll find that it's not very intrusive. So what we do with most of our products when we come up with a new idea is we buy all the competitive products. So in our research laboratory, we have 9 different machines that are very good for purifying air. And we take them and we say, what is good about this unit? What is the thing that's allowing them to have a place in the market? And we take that from there and we take all of them. And then we look at it from a dental point of view and say, what parts are really needed and what parts will make a difference to dentistry? And what we came up with this is DentAir. And it's a combination of technologies. So it's not just relying on HEPA, like some of them. It's a combination of a pre-filter, and then a HEPA filter, and then a carbon filter, then a titanium dioxide catalyst, then UV, and then air ionization. So quite literally, every technology that you can use for purifying air, we have in this unit. And it's also a lot smaller than some of the comparable units because we're very, very good at sort of concentrating technology and using them together. So you mentioned previously about the amount of wattage needed to eradicate the viruses. And we came up with similar figures to yourself. And we've massively over-engineered it in terms of how much energy we're giving those viruses so we can completely ensure the eradication in the air. So we're talking around 40 milliwatts per centimeter squared rather than 1.9 or 1.7, which is required. And on top of that, we have a titanium dioxide catalyst, which actually coats the inside of the carbon filter, which gives us a huge surface area. Now, one of the downsides to using titanium dioxide with UV is it produces ozone. But actually, because it's impregnated inside the carbon filter, it means we're absorbing that ozone at the same time. So we're well below the limits that are set out by the EU and USA standards. And what it means is we can then create a unit that's going to be very quiet because it's never running at full capacity. We are able to clear a room up to 120 cubic meters comfortably with this machine. We found most surgeries will be sort of 30 to 40 cubic meters, which means you're going to be turning over the air every 3 to 4 minutes. So most of the time, it'll only be running 20 to 30%.
Yeah. So I saw a study, I think it was by Boston University, they're recommending a dental surgery should be turned over something like 15 times per hour. Is that correct? Is it also the basis you guys are working on?
So the basis we're working on is the Public Health England guidelines. Public Health England states that in a surgery, you should turn over the air 5 times an hour. With our unit, you can easily exceed 15, 20 times. So we generally have 2 to 3 times the throughput of any machine of a similar size. So generally we find it's more 1 unit per chair. You're very, very rarely going to have to put multiple units into a single room. In terms of where to place it, what we've actually done is created technology in there which moves the air around your room. So rather than you having to put it in a very, very specific place, the machine will create that airflow within your room. So what it does is it draws air in the bottom, 360 degrees around the unit, and then shoots it out the top. So actually what you're doing is creating what is like a very large donut of air within your room. So it's pushing clean air out the top and then bringing the dirty air underneath. So as long as it's about 20 centimeters away from each wall, you'll get that kind of convection of air going around your room. Okay. The other thing that it has is something called reactive air kinetic technology. So this uses lasers to scan the air to detect particles and also volatile organic components. And with that, it gives you an air cleanliness score and will adapt the throughput of the fan according to how contaminated your air is. So when it detects, say, an aerosol generating procedure, the fan will increase in speed and deal with that, what's going on in the air. And I can actually demonstrate that now. So for example, this is a particulate generator, so it will generate 1 million particles per meter cube. And the machine will deal, I mean, generally bad air is 75, so we're talking magnitudes more. So what this will do is completely overwhelm the machine, but you'll find that it's still able to cope. So what you'll notice is it will draw all of the air into the machine, but no smoke will come out of the top. And you can see my lovely scrubbery wall being blown around by the air at the moment. So this is on maximum at the moment, and you can still have a conversation over it. On maximum, it will be around about the same volume as an air conditioning unit. So now I can blast the air into this thing pretty much consistently. And then see. So it's literally just absorbing absolutely everything.
That's pretty
and then
impressive.
As I stop, you'll notice in a second the unit will change and it will react to that. So it's increased the speed of air through the unit.
Okay.
And it will clear the room very, very quickly of any of the contaminants in the air. It's gone red. I'm not sure if you can see that on the camera. So it's now reacting, and they're going to drive through the air a lot more quickly to decontaminate that air. And you'll see it will quite quickly go back green again. If I zoom in here, so it's already gone back to yellow, and in a second it will go green once it's dealt with that amount of smoke.
Wow.
It'll go back to green already.
It comes with an app that you can download onto an Apple phone or an Android phone.
With that, you can monitor the air quality. It'll show you a graph of how your air quality differs through the day, not just for particulates, but also for organic components. So in some countries, they're doing air quality auditing, and to check your air quality, this will do it automatically for you.
I know some of these HEPA filters, I mean, do you have to wash them or vacuum them out? Or they're totally disposed of when they, after their period of time, which we estimate, say, an average once a year or something like that? What happens then with the HEPA filters?
Yeah, so there's absolutely no hoovering off or washing of these filters. We know with some of the competitor products, you have to do that once a week, but then you're relying on a filter in your Hoover not to push that, whatever you filtered out, straight back into your air. So we've created to have a HEPA filter, which is so much larger, so you can build up 6 to 12 months of use on a single filter, which is then replaceable. And I can actually show you how easy it is to remove the filter. You literally just turn the unit on its side, the bottom then unscrews, and you can take the filter out. So this is why you won't have to, unlike some of the other units, wash the filter, because it is so large. And then very, very easily, with standard PPE, you can put this into your standard clinical waste.
You spoke about close to £95 per year for the filters, for the two filters. And I think it was something like £46 for the bulbs, the lights. And if you estimate this to be taken over, I don't know, a 1 year period, but the servicing or changing these filters is dependent on the quality of air, I presume, that's coming through it.
From the testing we've done, funnily enough, if you're in the countryside, we generally find that the filters get clogged up more because they're drawing a lot of pollen and a lot of external contaminants. Likely, if you're in the center of a city, you'll get a lot more pollution. So it's not just based on the dental stuff you're pulling out of the air, because this is so good at removing everything in the air. It's completely dependent on how much stuff goes into the filter. But it also means that if you do suffer from allergies, you won't have any of those in the room anymore. So you'll have a noticeable difference in terms of allergies.
Then there's a question, does the humidity influence the air cleaning?
The higher the humidity, the more coagulation of sort of particulates in the air you get. But because this machine is very good at moving a large volume of air, it won't really affect it too much. If you have a high humidity, you'll notice the fan runs sort of higher for longer because it has to do more work. But actually, because it's capable of 120 cubic meters and you're probably using 30 to 40, it's not going to cause a problem for you.
Okay. Then just in terms of peace of mind, I've had some dentists asking me, okay, and I've had to explain to them over the phone that a lot of science was putting behind in terms of the wattage of the bulb, the surface, how many millijoules per square centimeter we need to kill the virus and so on. So the air comes in, it goes through the filters, the HEPA filter, the carbon filter, the pre-filter, and then it also gets the UVC. So in terms of what can pass through, because from what I can see from all the scientific literature and so on, a virus in terms of particle size, I mean, it's pretty small. It's like 0.01 micron to 0.4 micron, where bacteria is a lot bigger, talking 0.5 micron to 1.5 micron. And so if this is stopping 99.97% of, and also what I found out too, that the virus, because it's so light, it moves instead of a straight line, which theoretically should go right through a 0.3 HEPA filter, but because it moves in a zigzag way, because it's actually lighter than most of the air, it gets bounced around. And there are attempts to come together with other virus and get clogged in the HEPA filter. But then even if we've got 0.03% of viruses that potentially still go through the HEPA filter, they then being pretty much obliterated by the UVC. So the chance of any virus still coming out the top of your unit is I mean, it's pretty much close to zero from what I can make out. Is that correct?
Absolutely. So HEPA filters are rated as a standard of how well they filter out 0.3 micron particles, because these are the most difficult ones to filter out. Actually, smaller particles have a higher efficiency of filtration with a HEPA filter, but it's purely a standard as to why everyone quotes 0.3. So 99.995% of the viruses will be filtered out, because the corona, for example, is 0.12. So most of that will be filtered out with a HEPA filter. But anything that gets past that then has to go through catalyzed UVC. So actually the viral load, if you will, at the UVC is very, very low anyway. And then we're massively overkilling with the amount of UV that we've got. So the chance of anything out of the top are very, very minimal. And so you've got multiple stages of removing anything from the air. So the titanium dioxide, first of all, produces a huge surface area, which allows it's a bit like slowing down the air against the UV. So the UV doesn't have to act upon the virus for as long if it's in the titanium dioxide environment. And again, with other chemical reactions, so it just speeds up the rate of the chemical reaction. So any of your volatile organic compounds that you are breaking down, you're correct, will be broken down into water and carbon dioxide a lot quicker under the influence of the titanium dioxide catalyst.
And then the purpose of the ionization is essentially to go and create this negative positive field and then be attracted to some of the particles in the air, making them heavier, which brings them down to drop down either on your surface and use surface disinfectant, or otherwise obviously get sucked back in and go through the same cycle again.
Exactly, yeah. So negative, not just down because it's not affected by gravity, but it's affected to a positive or neutral charge. So any neutral. So most of this is dealt with within the machine anyway, because it will be charged and then attracted within the machine, because all of this happens in the UV chamber. So actually, we're not pushing negative ions into the air. There's not a lot of science to say that that's useful, but it's more about how it deals with things inside the UV chamber, the ionization inside the UV chamber.
Yeah. So pretty much from what I can make out and my limited knowledge on this, you guys are pretty much, you talk about the 5-stage filtration, and there's pretty much nothing left to really add to it from what I can see any other technology. And even the fact that you put the smart technology in to actually monitor the air for you and give you clean air audits and so on, I think that's actually amazing. So now originally, I know you guys didn't develop this during the COVID time. It came on long before that, because you were looking at something for dental surgery air. And so did you then increase something or improve something because of COVID, or was it pretty much always at this level of creation?
So we always look at other countries to see what they're doing in terms of dentistry, and we find there are a number of countries which are a few years ahead of what's happening in the UK. To take South Korea, for example, we're the main manufacturer of loupes in the UK, and our lenses are ground in South Korea. So we know what's going on very well in the dental world in South Korea. And they are massively well informed about air quality within the dental surgery. One of the studies I've seen say it's the second worst quality of air for any profession, because you're in a room constantly generating aerosols and you're not really allowed to have any sort of airflow through a window. So they make it mandatory to have some form of air purification in a dental setting. So we kind of looked at it and said, how long do we think it will be until the UK bring in something similar? So we started developing this unit. Mainly because we're sort of thinking about our own health. And when you think about the amount of people you come into contact with and your staff in general, if these people are just bringing in colds and flu, and you can remove those viruses from the air, that's going to be a huge benefit, regardless of all this COVID stuff going on. So that was kind of the way we looked at it. One of the things that we changed was the fact that everyone's really looking at viruses at the moment. And there was a little bit of people didn't really know what was happening if you're trapping some of the viruses in the HEPA filter, and they were worried that that was going to then be a problem. So we moved the UV to the inside of the HEPA filter and then created a peptide coating, which is antimicrobial. So you cannot have bacteria and viruses growing on the filter for 2 reasons. 1, the antimicrobial coating, and 2, the UV light is bathing those filters. So we kind of, as people got more educated to air filtration, we changed our design to make sure that we sort of put to rest anyone's concerns with a unit like this.
Yeah. There's another question here. How does the DentAir compare with the a Veria Pro 150 air purifier and other units on lexuspress.com for a tenth of the price.
Absolutely. So it's purely based on the fact that we've got science to back up everything that we're saying. So if you take one of the units you mentioned, the Veria Pro, for example, they have components in that unit which are kind of just tick boxing. So for example, they say they've got UVC, but it's A, uncatalyzed, B, it's a lot lower wattage, and C, the air doesn't directly pass over that bowl. So it's in there somewhere, but it's not doing the same thing that a medically rated device will do. The other thing is, when a lot of these will say that they have a HEPA filter, there won't be any standards on it. So there are loads of different types of HEPA. Anything can be HEPA. So down from an H10, which is around about 70% efficient, all the way up to, as I mentioned before, H15, which is 99.9997. So you'll generally find these ones a lot lower. And also, you're going to be able to do a lot less volume with them. They'll always quote on meters squared of the size of a room, but this is not based on a medical or dental situation. This is based on a home situation, which is suggesting 1 air change an hour, not 15 to 20. So what you'll generally find is they will the list of stats and components it has are more tick boxing rather than actually using. Some of the ones that we've seen, for example, use a single LED of about 500 milliwatts just to say that they've got UVC. Huge wavelength, broad wavelength UVC. It's not going to do anything to kill viruses. The other thing is, I know with the Veria Pro, you cannot change the UVC bulb unless you have an engineer coming out. So longevity of the machine may be useful in the short term, but actually long term, you're going to have to do a lot more to that than a different sort of unit where it's all usable, serviceable.
Yeah.
I think their one also is more aimed at kind of the hairdressing market and home environment, which is then they've said, oh, here's an opportunity, let's put it into dental, rather than being built from the ground up for a specific situation.
Yeah. Well, that's what I like so much about your system, and you being a dentist yourself. This was designed for a dental surgery way before we had this whole COVID-19 crisis. So then obviously you guys didn't just sort of jump on the bandwagon for it, and you've designed it specifically for the surgery. So I like that. So just in summary, from my understanding, from what I know, the 5 filtration system, the air comes into the bottom half of your unit. That unit, just by the way, is 80 centimeters high, just less than a meter, and 30 centimeters in diameter, and it weighs about 13 kilograms.
Yes, yeah, it's 15 kilos, but apart from
15.
Exactly.
Okay. And then all the filters and those kind of things, they designed. You don't need a technician or anybody to come out and change it. It is advisable, obviously, when you do change those HEPA filters, that you do put on your normal PPE protection and so on.
The half-life of a virus, take COVID-19, for example, is about 12 hours. So if you're particularly worried about that, change it on a Monday when it's been sitting there for the weekend. The viruses are not going to still be viable when they're on their HEPA filter. But actually, when you look at it more, because of the flow through of the air, it's an unbelievably in-hospital environment, so they're dried out within seconds. So chances of anything living on there are very, very remote, especially with the peptide antimicrobial coating on there. It's unlikely, but just best practice is to use PPE because we have it in abundance and available anyway. So that's what we recommend.
Okay. And you're actually supplying these units to some of the dental schools and the hospitals and so on currently in the UK?
Yes, absolutely. So we're working with big open plan spaces, up to 160 chairs on one floor. And the great thing is because it's all digitally and app integrated, they can work together. So we can actually do any size unit that you throw at us. We can create a sort of combination of them to make it work.
One more question here. Does it matter where your aircon is positioned in relation to the unit?
So you have 2 different types of aircon generally. Sort of a central air system where you've got external air coming into the room. And then you have an aircon unit which is circulating the same air but cooling it down.
Yeah.
Now, the circulating the same air but cooling it down is very, very simple. No, it doesn't really affect it at all because of the throughput of the machine. If you put it directly under, the machine will work a little bit harder because it's got to move the air around, including the air that's being moved by the air conditioning unit. But it's massively overpowered anyway, so it's not going to cause a problem.
Yeah.
If you have air conditioned from a central unit coming in, you have to include the amount of air coming in your calculation of your room size. So, for example, if you have 30-meter cube room, but then at the same time, you've also got 30 cubic meters of air coming in the room every hour in addition to, you then add that to your calculations. But again, because the unit is hugely overpowered, unless you've got a torrent of air-conditioned air coming in, it's very unlikely to cause it. It'll just cause the unit, once again, to operate on a slightly higher level. But it'll do that automatically because of the React technology anyway.